What's up, mathletes? This is your boy, Mr. Bergman here, coming to you, talking to you about the degree project. Very excited about this one. Here we go. Frequently asked questions. First of all, this is a partner project, so that means you're going to be in groups of one or two. When is it due? It's going to be due after 2 full class periods to work on, and it's due on the third class. What are you going to turn in? Video recording on Google Classroom, same as always. What is it worth? 100 points, same as a quiz. What are you going to do for a good grade? Well, you should preview your work with me and also check the rubric, which is going to be the same, although we're not going to use all of it. As you might see, as I want to let you know that requirement number 5, event analysis, there's only a central question and other related questions. There's actually no graph. You're going to be using Desmos a lot, but there's no graph we're going to make, so therefore no full graphical analysis. And then requirements 5, A, B, D, and E just don't make any sense if there's no graph. Why? Why are we doing all this? To solidify Chapter 5 concepts. But even more than that, I want you all to get really good at tackling tasks that are given to you by someone else and reporting your findings. I want you to be able to really tell a research story in the format of a STEM presentation. There's no test during this time. There's no alex.com assignments. There's no Desmos group investigations. But on that third day, when the project is due, I also want you to turn in Edpuzzle 6.1 so we can start Chapter 6. All right, here we go.
All right, check this out. This is the National Weather Service Heat Index. And so what you can do is, if it's super humid out, like often it is during the summer here in Philadelphia, and you know what the temperature is, you know the humidity, the relative humidity and the temperature, then you can figure out what the heat index is. And it's kind of like, well, it might measure with a thermometer 94 degrees, but if you got 80% humidity at 94 degrees, that's like, it'll feel like 129, which is super hot. And this is the kind of thing they can make recommendations where you should, the likelihood of heat disorders with prolonged exposure or strenuous activity, like don't play sports outside when it feels like it's 136 degrees. So that's what this is for. Here's a central question. How can you extend the heat index table? You notice that there's all these blanks here, and notice that it's getting hotter outside with global warming. So we might need to extend this, and I want to know, how can we do it? We're going to need to talk about some variables and constants. The heat index is the output variable. It's measured in degrees. So you can say all of these numbers here inside of the rectangle are the heat index, and it's the output. And the two things you need to do to collect in order to produce the output would be the humidity, which is measured in percent, and it's one of the two input variables, and the temperature, which is also measured in degrees. It's one of the two input variables. Then they have all these constants. We're going to talk about constants in a second. But they're like the slope, like, y equals mx plus b. They're like the slope or the y-intercept, m or b, just used to adjust a curve to data. And we've already used constants before. When we had a strobe light parabola project, we had a whole lot of data, and we used that data to figure out what A, B, and C are. These were the three different constants. So the top line was a regression, and that tells Desmos the squiggle line tells Desmos to look at the table that has a column x1 and y1 and somehow come up with the best possible A, B, and C values that could fit everything into a parabola. And it worked really well, and that's what it looked like over here. And then you could also reference those A, B, and C values to come up with a function and make a prediction. So with a new x value, you could use the already calculated A, B, and C values to come up with a new output function. The input was the x-coordinate, the output was the y-coordinate, and we decided it was going to be quadratic in nature. Here's what the heat index is going to look like. We have to do the same kind of thing. The first thing we have to do is identify our variables. The input is going to be, we have two input variables, the temperature and the humidity, and the output is going to be the heat index. And we want this also to be quadratic in design, just like a parabola project. And then also, just like the strobe light parabola project, we have to make a table on Desmos, and you'll have an H1, T1, and I1. These two are the input, H1 and T1, and then the output would be the I1. And so here, what we have to start doing is we have to start putting a whole lot of data onto on a Desmos, more than any other project that I'll ever assign you. Usually projects, if they have just a couple of constants, they need like, I don't know, 20 or 30 data points, and then usually that's enough. It's pretty good. Here we're going to need a lot more, and we need to make sure they're not all clumped in the corner. I've got the first 4 right here, but you're going to need to choose a whole lot of data from this, 30 plus rows representing data from all corners and regions of the colorful National Weather Service heat index table. You have to type in the heat, the H, the T, the relative humidity, and then the temperature, and then the index. 3 different numbers for each of these different locations, and you need a whole lot of them. So my advice right now would be to pause this and go ahead and do it. Pause the video and pull up a Desmos and then start entering a whole bunch of data. Make sure it's spread out. You need this one right here, 136. You need this one, 132. You need this one, 87, and a whole bunch in between as well. And now that you've done that, you might want to save your Desmos, but we'll come back to it later. You can also get started on something else. Oops. Let's get started on the notes. Quadratic in nature means that we want to assume that the humidity is going to be quadratic, and we want to assume that the temperature is going to be quadratic, and therefore we're going to have three constants here and 3 constants here for a total of 6 constants to start out with. But if you were to multiply them together, like we know how to do from chapter 5, the 3h squared, I'm just picking random numbers, 3, 2, -4, 5, -3, and -2. In reality, they're not going to be very easy like this at all. They're not going to be very simple. So we've got this, if you multiply this together, you get 3h squared plus 5t squared, because you have 15h squared t squared. 2h times -2 is going to be this -4h, and -4 times -2 is +8. So if you're going to multiply these two together, you would write all this out. I'll give you a moment, pause the video to copy the whole thing down. And now that that's copied down, you have a concrete example of what we're doing, and now we're going to make it a bit more abstract. So what we need to do is we need to actually multiply these constants together without knowing what the constants are. We haven't even, the constants are predetermined from the National Weather Service, but we don't know what they are, and in order to discover them, we have to first multiply them in a way that allows us to multiply them without knowing what they are. So basically what we're going to do is it's going to look like this. This C constant, this as you can see here, -2 and -4, these are different numbers. But because this is ABC, ABC, these are 3 different numbers, and these are 3 different numbers. This constant times this constant will give you a completely different constant over here. And we don't know what the first C is, we don't know what the other C is, and we certainly don't know what the product of those 2 numbers are either. But we will once we type it all into the Desmos. This B times T times this C, we don't know what the B is, we don't know what the C is, and we certainly don't know what their product is. So we're just going to call it a different C number 2. And you can see the variable is T here. This constant, we don't know what it is. This B, we don't know what it is. But if we multiply them together, we're going to get a completely different number, and we have no idea what that is either. And it's going to be different from the other constants as well. So this could be the 3rd constant. And because this H variable is here, the humidity variable is going to continue here. You keep on playing this whole game, 9 squares. I'm going to let you fill in the blanks here. This is A t squared times B h. This A and B are obviously very different, and when you multiply them together, you're going to get a number that's we haven't used yet at all. We have no idea what it is, and we'll find it eventually. But right now, we have to give it the name C7, and then 1h here and two t's here. C7 ht squared. This AH squared, AH squared times BT is going to give you C8 H squared T. It's the 8th constant that we don't know what it is. We'll eventually find it, but for right now, we just need to call it C8. And this A is different from this A. This AH squared times AT squared, well, A times A, we don't know what the numbers are. They are different, and when you multiply them together, you get a completely different number, and we have to call that C9 because there's so many constants. C to the, this is not an exponent, remember, it's a subscript. It's differentiating the name C9 from C8, from C7, from all of the C's, and then H squared T squared. So what do you get when you multiply two different trinomials together whose coefficients you have no idea what they are? Well, you're going to get a total of 9 different terms: C1, C2, C3, all the way up to the C9th term. And what I'd like to do is I'd like to let you take a moment right now to fill in these boxes as best you can. The order actually doesn't matter. You know addition. They could be swapped order. The C9 term could come first if you really wanted it to, and the C1 term could come last. There should be 3 terms here from these 3 missing boxes, and you can go ahead and fill them in. So then you can type this all in Desmos, and once you get your 9 terms, you can say I1 is make a regression from C1 all the way up to C9 h squared t squared. You can type that on Desmos. And then type this on Desmos also. This is your function. You remember back in the Strobe parabola project, we had 2 very important lines. This line, the regression line, was the one that calculated the constants in the first place, and then the function line was the one that used the constants that were calculated to produce a prediction or to fill in the gaps wherever needed. And we're going to do the same thing here. We have 2 different lines on Desmos, one that references the table and the data and calculates the constants and tells you what the best constants would be. And then you're going to have a second line, a function line, that's going to use to make predictions. So we've got C1, it will know what C1 is because it calculated it on the previous line. It will know what C9 is. Notice this I and this I. This I has a 1 subscript referencing the data, and this I does not have a 1, indicating that it's a new function. And so the same thing here. Yeah. So h comma t. These are the variables, and it knows what the constants are. I want you to write this in on your packet because you did your chapter 5 work really well, and you know how to multiply polynomials together. Type this on Desmos, and then you should be able. It should just say, "Okay, that's great. Thank you for the function." What you can do next is start to check to see if it actually works. So if you've got a Desmos table and if you want to check, you can type in I parentheses 70 comma 80 parentheses, and if you've done everything right so far, it should produce 83. That's the number right here. You notice 70 humidity and an 80 temperature should give you 83. And if it does, then you've done a lot of work correctly so far. And if it doesn't, don't worry. We'll take a look and see. We can spot check and we can problem solve when we get into class. But you can type in I45 comma 108, and that's way over here. If the humidity is 45 and the temperature is 108, it really feels like actually that should be 137, not 107, from just looking at the table. Okay, and you should do some more checks as well. Check to make sure, not only should you circle the numbers from the data table just to make sure that you can see which numbers you have on the data table, but you can also make a check mark on your data table as well, and indicating that you've checked those regions. And then you can even start making some near predictions. What if these are correct, then you can even start making some new predictions over here, like I 90 comma 94. That's not on the table, but you should be able to extend it if everything checks. If you've got your Desmos table and these internal checks line up, then you can start extending the table and making some near predictions, like over here. What exactly should this be if the pattern follows? What exactly should this be over here? 110 is over here. 104 is over here. Some far predictions and some numbers that are all the way off on the far reach. You can add those to the table. And if you can do all that by the time class starts, then you're in a great position. Even if you can do some of it, or even if you kind of understand what's going on, you're still in a pretty good position. So there are some related questions, and maybe it's best to talk about that on day 1 or on actual day 2 of class. We don't need to do that right now, but here they are. And there are some helpful links to help you answer those related questions. And go ahead and get started. There are 3 things you can do. You should be able to fill in. You should be able to bring to class the notes that I've shown you, and also perhaps some of the things I've filled in. You should have something started on a Desmos table, and you can even start your own. You can even start your own Google slide if you want. So there it is. Thanks for watching, and I'll see you in class.